find the equivalent resistance between the ends A and B, and we are going to use method of symmetry to find the equivalent resistance. So we see that this network is quite symmetrical. If we connect a battery between these two terminals, let's say we connect a battery. So there may be some current which is, let's say it is going, I1 is going in this direction, I2 is going in this direction, and let's say we are taking just some currents that let's say I2 is going in this direction. Right now we are just bothered about that is what is the current which is flowing in this arm and this arm, because eventually we shall be talking about this connection. Had this connection been not connected over here, then all the things they were quite simple, that is series and parallel, we could have done it. So let's see, though there are going to be other currents also, but for a time being, let's concentrate on these two arms, this and this, these two resistors. Right now we are concerned about the current in just these two resistors, this resistor and this resistor. There are going to be currents in other arms also, but right now we are just concerned about these two resistors. Over here we say, let's say the current is in this direction, and over here the current is in this direction. It may be in this direction, it may be in this direction, but obviously over here the current is going to be in this direction. Now we see that is current is flowing in this direction. If we reverse the polarity, now current I1 shall be flowing in this direction, and over here the I2 shall be flowing in this direction. This is going to be how the currents are flowing, because whether we flip this network or we flip the battery, that's one and the same thing. So it means that is, if you flip it, that is, instead of now going the currents I1 this way, the current I1 shall be going this way. I2, instead of going this way, now because it has been, battery has been flipped, the polarity has been reversed, I2 shall be flowing this way. So it means if initially the currents they were going in this direction, in this arm I1 this way and I2 this way, if they were going in this direction, if we reverse the polarity, we make it positive and we make it negative, then certainly I1 and I2 in these arms, now I1 will be coming this way and I2 will be coming this way, and these currents they will obviously change their direction because the polarity has been reversed. So now the direction is going to be reversed, I1 is going to be in this, and in this it is going to be I2. This is how the direction of currents that is going to change, obviously, because polarity has been reversed, the direction of currents will be reversed, because the currents whatsoever going this way, that now the same currents will be entering this way. Had it been earlier, if we had assumed the direction of current in this direction, then it would be reversed accordingly. So now what this means is, at this junction, if we see what is happening is, I1 current is coming from here and it is going over here. I2 is coming from here and I2 is going over here. It doesn't make much sense if we say some of the current from here is going over here and some of the current is going over here. The current is I is equal to dq by dt. It is not some blue color water or red color water. That is some water from here, it has gone over here, and its water has gone over here, so it has a mixed over here. I is equal to dq by dt. It is because of flow of electrons in these metals. So even if we say, that is, if we slightly separate it and we do it like this, we separate this junction and now current is I2 and I2, I1 and I1, still we have not disturbed, that is how the currents they are flowing. Still we have not disturbed the equivalent resistance of this circuit between the points A and B. Still we have not disturbed how the currents they are going to be divided. So now the things they are much easier. We see that this R and this R, they are in series. So this can be equivalent as, this is R, this is 2R, this is R, this is R, this is job done, this and this we can directly say 2R, over here is A and over here is B. R and 2R, that is in parallel. So if we say 1 by R dash is equal to 1 by R plus 1 by 2R, so 1 by R dash is equal to 2 by 2R plus 1 by 2R, so 1 by R dash is equal to 3 by 2R, so R dash is equal to 2R by 3. So what we can do is, this and this they are parallel, we can call this as 2R by 3, this is 2R by 3, this resistance is here, this resistance is here, and this is 2R, and these are ends A and B between which we have to find the equivalent resistance. Now 2R by 3 plus R, they are in series, So they make 2R by 3 plus 2R. R plus 2R by 3 plus 2R, they are in series, so we can simply add it. So 3 to 6, 6 to 8, 8R by 3. This is, we can replace these three resistors by a single resistor of 8R by 3. So this makes 8R by 3, and this is 2R, this is A and this is B. Now these two resistors, they are parallel. Once again we can say 1 by R double dash is equal to 1 upon 8R by 3 plus 1 upon 2R, which comes out with 3 upon 8R plus 1 upon 2R. So 1 upon R dash is equal to 3 plus 4 by 8R. So R dash is, R double dash is equal to, so RAB comes out to be 8 by 7R. This is the equivalent resistance between A and B. So over here, if each resistance is equal to R and we have to find the equivalent resistance between A and B, on the same lines what we can do is, whatsoever the current, let's say if we say this is a battery, we have connected to a battery, and let's say current I1 is over here, I2 is over here, and I3 current is flowing in these resistances. So we are considering just the resistances which are connected to this, the central junction. So if I1, I2 and I3, let's say they are currents, obviously there are the currents in the other resistances also, but we focus primarily our attention in these three resistances which are connected to the central junction. Now when we reverse the polarity, that is if this is flipped, now this is positive terminal, this is negative terminal, when we flip it, so this becomes positive terminal and this becomes negative terminal. Now the conventional current, instead of going from here, it will be going in this direction. So if earlier I1 was flowing in this resistance, now I1 will be flowing in this resistance. If earlier I2 was flowing in this resistance, because of symmetry now I2 will be flowing in this resistance. If I3 was flowing in this resistance, so the equivalent is I3 will be flowing in this resistance. And now because the polarity has been reversed, whatsoever the currents earlier they were flowing in the circuit, they will reverse their direction. So it means this will reverse its direction like this, and this will reverse its direction like this, and this will reverse its direction like this. So what we see over here, that is I2 comes over here, goes over here, I1 comes over here, it goes over here, I3 comes here, goes here. So even if we separate this, so over here if we separate this junction like this, it means we have not done any changes as far as the equivalent resistance between A and B is concerned. Whatsoever the equivalent resistance had been earlier, the same equivalent resistance is right now also, because we have not disturbed the current distribution in the various arms of the circuit. When we say resistance, it is the opposition offered to the flow of current. Whatsoever way initially the current was flowing, it is still flowing the same way only. But it has made our job much easier, because now it is only a combination of series and parallel resistors. This and this they are series, this and this they are parallel, this and this they are in series. Same thing goes for this, we can find it. Then this and this they are parallel, and we can easily find the equivalent resistance between A and B. This is one way we can use the method of symmetry to find the equivalent resistance. Though we could also find the equivalent resistance between these two using the star delta method, but over here this is much simpler as compared to star delta method. But had there been any resistance which is different, let's say all the resistance they are equal to R only, and let's say this is changed to 2R, now we cannot separate this, and now all these they are connected over here. In this case, when it is 2R, it is not symmetrical. It may be advisable to use star delta transformations in that case.